Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Cold dilute KMnO4, Bayer's reagent, performs syn-dihydroxyl of alkenes, adding two OH groups to the same face of the double bond, syn addition, producing a diol. For the product to be a meso compound, two conditions must be met. 1. The diol must have two stereocenters. 2. The molecule must have an internal plane of symmetry, making it achiral despite having stereocenters. Moving on to the next step. Both OH groups add to the same face, giving syn diol. Moving on to the next step. Determine which alkene gives a mesodiol upon syn addition. A meso compound requires that the two stereocenters be identical in substitution but have opposite configurations that cancel each other out via an internal mirror plane. For syn addition to produce a meso compound, the alkene must be cis, same substituents on same side, and the carbon chain must be symmetric about the double bond. And for the final step, A. cis-2-pentene, CH3, CH is equal to CH, CH to CH3, cis. The substituents on the two carbons of the double bond are CH3 and CH to CH3, these are different. Syn-dihydroxyl gives a diol with two different substituents at each stereocenter, so the two stereocenters are not identical. This cannot be meso. B. cis-2-hexene, CH3, CH is equal to CH, CH to CH to CH3, cis. The substituents are CH3 and N-propyl, different. Not meso. C. cis-4-octene, CH3CH to CH2, CH is equal to CH, CH to CH to CH3, cis. Both carbons of the double bond bear identical N-propyl groups. Syn-dihydroxyl adds two OH groups on the same face. The resulting diol is 4R5S or 4S5R, but because both stereocenters bear identical substituents, N-propyl and H and O, and since syn addition on a symmetric cis alkene gives the same configuration at both centers from the same face addition. Wait, let me reconsider. For cis-4-octene, symmetric alkene, syn addition gives the 4R5S diol which has an internal plane of symmetry, this is the meso compound. The molecule is CH3CH to CH2C, or H, C, or H, CH to CH to CH3, which is symmetric. With syn addition, both OH groups are on the same face, giving configurations that are mirror images of each other across the internal plane, hence meso. D. Trans-2-hexene, syn addition on a trans alkene with different substituents does not give meso. The key is symmetry of the alkene. cis-4-octene is symmetric, N-propyl on both sides, and cis. Syn-dihydroxyl of a symmetric cis alkene gives the mesodiol because the two OH groups added syn to one face create RS configuration at the two identical stereocenters, resulting in an internal plane of symmetry. Note, for a symmetric cis alkene, syn addition mesodiol. For a symmetric trans alkene, syn addition RSS racemic mixture. Options A, B, D either lack symmetry or are trans. Therefore, the correct answer is C. Therefore, the correct answer is option C.